A very good morning to all the students. I am Dr. HimaBindhu from the Department of Mechanical Engineering, and I will be dealing with the subjects robotics. And my today's topic is material transfer and material handling. What do we mean by the term material transferring or material handling? Yes, so generally any particular industry or any particular manufacturing factory, if we take, we have n number of components being designed or manufactured, right? So this will be a continuous project. It will be a continuous work which will be done in the factories or industries, right? Where if we are selecting, where if we are selecting the labors to transfer the products from one place to the other, or to lift the products from one place to the other and move the products, right? It will be a time taking process, and it doesn't give much accuracy, right? So when we are selecting a robot, right, a particular robot is being manufactured to transfer the objects or transfer the products from one place to the other, or to handle the products, that is to lift and pick and place the projects from one place, and to load and unload the products, right, with a good accuracy at a faster time period and with low cost efficiency. So that is the reason why robots have been introduced in material handling systems. Right? So material handling in robots involve the use of the systems to transport, that is in order to transport the products which are being manufactured, to move the products, to store the products in the required containers, to control the particular products, whatever are being designed and manufactured, and to protect the materials and product throughout the process of manufacturing. That is the use of material handling in robotics. And not only that, this particular products, it is a continuous process, as I've told you. So the manufacturing, warehousing, or the distribution, consumption, disposal, all these are a continuous process. So when we need to go for a continuous process, if we take something which has been automated, it does our work easier, right? The work whatever is to be done will become easy compared to the hard working system. That is, generally any person requires to do a smart working rather than a hard working, right, nowadays. So that particular smart working of material handling or material disposal or the material distribution or the material transport or moving the material or storing the material, we will be doing all this with the help of the robots in order to reduce the labor cost and to enhance the safety of the workers, right? In order to enhance the safety of the workers, in order to improve the efficiency of the work and to reduce the cost, we will be using robots. So as we can see in this figure, right, we can see in this figure, so what is happening in this figure? We have n number of robots, right? So this particular material which is being lifted with the robot cannot be done with a single labor, right? Three to we require 3 to 4 labors to do this work. In order to lift this particular product and move this product from one place to the other, we require minimum 3 to 4 labors. Now, in order to reduce this and in order to increase the efficiency and in order to reduce the time taken, we are using the robots which is doing the work of 3 to 4 labors within some 5 to 10 minutes of duration. Now the same work which is being done by these people will take at least 40 to 50 minutes, whereas the work being done by a robot is taking around 10 to 15 minutes. Now, depending upon the type of the application, right? Depending upon the type of the application. Type of the application is depending upon the requirement, that is whether to transport or whether to move or whether to store, whether to pick and place or whether to manufacture, whether to use in warehouses. We will be using different types of robots, right? So we are using different types of robots depending upon the type of the application. Now, that is, first let us see what are the important components of the robots, right? In order to do the material handling, what are the important components? First, we need to look after the robotic arm, right? Robotic arm is used as a primary tool for handling the material, which has been equipped with the end effectors like grippers, suction cups, magnets to manipulate the object. That is, here we will be having different types of the end effectors depending upon the requirement, as I've told you, right? To pick and place the object, we require the end effector which is having uh, uh, a grip, which is having its particular end effector will be in the form of our fingers, which will pick the object and place at some other point. For example, in the previous figure which we have seen, this particular robot is having a suction type of the end effector, right? This particular type of the robot is having a suction type of the end effector, as we can see here, right? So here what is happening, this is the robot which is having grippers, which is having the gripper which is picking and placing the object on the conveyor, whereas this type of the robot is having some suction type of the end effector, which is sucking the object and lifting the object, right? And this is a type of the rope type of end effector, right? This particular robot is having a rope type of the end effector which is lifting the object with the help of the ropes. And some robots will be having hook type of end effectors, like we have seen in the cranes, right, which will lift the heavier objects. So depending upon the requirement, the end effectors will be changing. If we go for any electronic manufacturing companies, there we cannot use suction type, or there we cannot use gripper type type of end effectors, because there we will generally manufacture small circuits, or we generally manufacture small type of the chips being generated. So for that we require magnetic type of the end effector, right? That is, since they are very minute parts, when we use any suction or when we use any gripper type, it there is a possibility that that particular chip or the circuit will get damaged. So there, in such type of industries or factories, we will be using magnetic type of the end effector, where it is uh, uh, where that particular requirement will be satisfied in that particular area. So next, moving on to the conveyor type of the system. Conveyor, that is one type of the transport system. So other type of the material handling system can be done by conveyor, as we have seen in this figure. Here what is happening, it is conveyor type of the system, where we are placing the objects on this conveyor with the help of the robot, and the objects are being moved from one place to the other, right? So we will be using a conveyor type of the component, where it is used to automate with the help of the belt transport material within a facility often integrated with robotic arms for loading and unloading. That is, we are loading and unloading the objects with the help of the robot, and the movement of the objects from one place to the other place is being done with the help of the conveyor system, which will reduce the time. Next, moving on to the next type of the component is automated guided vehicle, AGVs. That is, there what is happening, the mobile robots that follow predefined paths to transport the material across different area of the facilities, that will be done with the help of the automated vehicle. Automated vehicle is nothing but within the factory we will be having a vehicle which will plan its path priorly, right? and it will be working within that particular surroundings, right? So that is called as an automated guided type of the vehicle. And next is the sensor and vision type of the system. Sensor and vision type is nothing but it enables the robot to perceive its environment and to identify the objects and ensure the precise handling. That is, the robot, whatever is being manufactured, will be placed with some sensor and vision system, where with the help of that particular sensor and vision system, the robot can sense what are the obstacles been coming in between, and it will act accordingly, right, without damaging the object, right, without damaging the object during the material handling or material transfer. The robot will sense its environment and it will identify the objects, whatever obstacles, whatever are coming in between, and it will act accordingly, right? Next, coming to the control system. In the control system, what happens? We include hardware as well as the software to program and control the robotic system, ensuring they operate efficiently and safely. That is, here in the controlling system, what we do, we are inserting a program within the control system of the robot, and whatever is the work to be done by the robot, that will be done with the help of the program what we have inserted in the control system. That is the step by step process to be done. That is, first pick, suck the object, lift the object, and then place it on the belt conveyor. That is the program, 3-step program, which we generally give to the robot for pick and place type of the material handling, whether it is some other type of the material, that whatever is the requirement, that particular type of the program will be inserted within the control system of the robot, and the robot will be acting according to that particular programming, which ensures the efficiency and safety of which also ensures the efficiency and the safety. So here, the most important key components are robotic arm, conveyors, sensor, and the control system type of the components are very important, which we need to study. So, what are the various applications where we can use these material handling system? Where can we use this particular robots for material handling system? What are the various applications? As I've told you, generally we can use in manufacturing units, we can use in healthcare sectors, we can use in food and beverages, we can use in automotive industries, we can use in warehouse industry. What happens in the manufacturing industry generally? What do we mean by manufacturing industry? That is nothing but assembly or disassembly of the objects, for welding and painting and packing of the objects, for streamlining the production lines and ensuring the consistency quality. We will be using the robots in the manufacturing system. When it comes for warehousing and distribution, robot is used in picking and packing and sorting the goods, improving inventory management and order fulfillment. There we generally use the robot in the warehouse industries. In healthcare sector, we use the robot for handling the sensitive materials like medication and specimens, ensuring sterility and precisions, or for throwing away the waste disposals, lifting the waste disposals and throwing away in the required area. In those sectors, we can use the robots in the healthcare sector. And when we come across food and beverages, as we know, if all the nowadays the situation is not good. So when we are using human power in food and beverages sector, what happens? The hygiene of the particular food packing will get destroyed. So in order to reduce that particular deficiency, we are using robots to do all these automated works like packing, sorting out, or maintaining. In order to maintain the hygiene standards and efficiency, we are using the robots in food and beverage sectors. When it comes to the automotive type of the industry, we generally use the robots for heavy and repetitive tasks like assembling the parts, for welding, painting, enhancing precision, and reducing the human labor type of thing. We use the robots in the automotive type, as we have discussed in finance before, right? what are the advantages of using these robots? What gives us, as I've told you, it increases the efficiency. It is used for safety purpose. It is cost saving because we are reducing labor cost. It is more flexible because the labor, when they work, right, they work from 9 to 5 or 9 to 6, something like that. So here when we use the robo, this particular robo doesn't get tired, and it can work 24 by 7. So it is more flexible in work in any environmental condition, as well as in any particular type of the time constraint. So modern robots can be reprogrammed for different tasks, making them adaptable to various applications. That is, when after in the manufacturing units, as the work is to be done continuously, and one work assigned to the robot, and the remaining works are again reprogrammed to the same robot, and the work is being done. So that is known as flexibility, where reprogramming for different tasks can be done, and the robot will be acting according to the program which we have given, right? And why we are telling it is cost saving is, it reduces the labor cost and the operational expenses in the long term, and it is more safer, right? Because robot is not getting damaged, or it doesn't get any particular type of the constraints, like for example, when we are taking any particular painting industry or painting company, so the chemicals whatever we are using are very toxic. So when we are when we are spraying the particular paint onto the required object, the sound whatever is being disabled, with that particular sound, the human ears are being damaged. So in order to reduce all that constraint, in order to reduce the toxicity of the chemicals to the human labors directly, or in order to reduce the damages being occurred by the sound waves from the spray, we are using the robots which are used to handle uh, dangerous tasks, and to minimize the risk of the workplace injuries. Right? There may also be some injuries be taking place in the heavy industries. So, in order to reduce all that, when we are using the robots, it become more safer, right? Precision. When it comes to precision, the robotic system ensures high accuracy and repeatability, reducing the errors and improving the product quality. In order to improve the product quality, and in order to do a continuous repetitive work with high accuracy, we should use the robots. Increasing the efficiency. That is, robot can work continuously without breaks, increasing throughput and reducing the cycle time, as I've told you just now. It works 24 by 7. The robot will be working 24 by 7, which doesn't have any time constraint. That is the reason why it is one of the advantage we are using robots in industries. So, what are the various challenges we coming? So, when we come across the material handling in robotics, it is one of the rapidly evolved field with significant implication for n number of industries. When we take large scale industries, or when we take a small scale industries, the application of the robotics has been evolved in such a way that it has become one of the must awaited thing in the robot. That is, by leveraging advanced technologies to the companies which can enhance the efficiency, safety, flexibility in their particular operations, and innovative and sustainable practices to be done. The robots are to be introduced in the factories. So the one of there are few challenges which are coming across when we are using robots. That is job displacement. That, when we are using robots, what is happening? We are reducing the job availability for the other people, because when we are using one particular robot, we are removing around 20 to 30 labors, right? So it is reducing the job displacement. As the automation has been increasing, the requirement for the workers has been decreasing. So that is one of the disadvantage. And the maintenance is more. Once the robot comes to maintenance, The maintenance is, though the investment cost is one time, but when it comes to the investment, maintenance, its maintenance is a bit that is, it requires regular maintenance and updates to ensure the optimal performance of the robot. Coming to the complexity, the integration robots into existing process require expertise and careful planning. In order to have a complexity, it is more complex, as we know, the design, the manufacturing, or programming, giving a program to the robot. It is a bit, we require some careful planning to be done to enhance correct product to be product output to get. We need to do a careful planning. And next, high initiative investments, where it is, as I've told you, in order to purchase any robot, the first initial cost, investment cost, is more. That is, purchasing and installing robot system can be more significant, and it is more cost effective. So these are the challenges which we generally have to take care of and start any particular industries and start any particular robots in the industries. So generally, the material handling or the material transfer system in the factories or industries will be is more useful in order to reduce the labor cost, in order to reduce the time, in order to increase the efficiency, and in order to increase the accuracy, and in order to increase the repeatability, time constraint, safety, looking into the safety of the workers. The robot play a very important role and very crucial role in material handling or transferring. So depending upon the type of the application, the robot's end effectors will be changing, whether it is a suction type or gripper type or any particular magnetic type. So as we have discussed, depending upon the type of the requirement, that is here we are seeing, right? So depending upon the type of the application, we are using this particular robots, right? So these are the differences which we can look into for further extension, right? So in the next class, we will be seeing what are the various applications in where we can use this particular robots, different applications. We will be seeing about the future scope of the using the robots in industries and all. Right? Hope you have understood today's class. Signing off for today, Dr. G. HimaBindhu.
Like, share and subscribe. Hit the bell icon for more updates.